So we've got an animated GIF, or it's a GIF. Mm-hmm. So we have an animated GIF or JPEG in this case, okay? And it's showing us how to draw an ellipse or an ellipse, okay? We have 2 points. Those points are called our foci, and the British pronunciation of that is foci. So you'll hear it either way. Okay, we have 2 foci, and we have 2 strings basically here. Those 2 strings together are always a consistent distance apart. Okay, and it's creating an ellipse. Definition of an ellipse is the set of the points x and y in a plane whose sum of the distances from 2 distinct fixed points called foci is constant. 1 focus, 2 focus, 2 foci. An ellipse is the set of all points x, y in a plane, the sum of whose distances from 2 distinct focal points called foci or fixed points is constant. In addition to those foci, we'll have a center, and we'll have 2 axes, a minor axis and a major axis. Our book talks about the places where the major axis intersects the ellipse as the vertices. We have 2 vertices. Some books call them the major vertices. Our book does not talk about the minor vertices, but we will, just so we can have a frame of reference when we draw these, when we sketch them out, we have something to call those. So we have a major axis, a minor axis, 2 vertices on the major axis. We'll call those the major vertices. 2 vertices on the minor axis, we'll call them minor vertices. A center, and 2 foci. Okay. I got your pictures drawn, notes taken. More there? I'm sorry. So close. Give you a few more seconds. All right, so I have a Geogebra example, so you can see how this works. So we have this ellipse, and we have a point on here that is tracing its way around. And notice how those 2 distances are always, the sum of those 2 distances between the foci to the ellipse is always consistent. Doesn't matter where we go. I can change this point and make it have a major axis that's vertical or a major axis that's horizontal, right? I can make it almost circular. In fact, I can make it a circle if I'm precise enough. So a circle is a very specialized ellipse, but those two distances between the foci and that point on the ellipse are always going to be the same. The sum of them will always be the same. Okay? So the standard equation of an ellipse varies depending on whether it's a horizontal ellipse or vertical ellipse. Both the x and the y term are squared, unlike the parabola. Parabola had one of the terms squared, the other one was not. Both have a number below them. There's a plus sign in the middle, so we know it's an ellipse, and they're both equal to 1. What's the difference between the two equations? The a squared and b squares are switched, right? So 0 is bigger than b is bigger than a is your largest one. That denotes where your major axis is. B is always your related to your minor axis. Okay. Our center of our ellipse is going to be HK. Our foci for our horizontal ellipse will be H plus or minus C comma K. And our vertices, our major vertices on a horizontal will be H plus or minus A comma K. On the vertical ellipse, same center, our foci will be H comma K plus or minus C. And our vertices will be H comma K plus or minus A. And again, we won't spend a lot of time memorizing formulas. We want to understand how it works and go from there. So we're going to graph them and make them make sense. The length of the major axis is always twice A. So whatever this number is, we'll take the square root of it from the center to the left and to the right on a horizontal will be our major axis. That'll help give us our vertices. Minor axis is always going to be 2b, so we'll take the square root of whatever's below our y squared in the horizontal case or x squared in the vertical case and count that much up and down. That will get our minor axis. So we're missing one piece here, right? We've talked about A. 2a is the length of our major axis. B, 2b is our length of our minor axis. H and K are consistent from what we've been working with, the centers now instead of the vertices. And what's missing? C. We don't know where in the heck C is and where it comes from. Okay, so C is derived by taking a squared minus b squared. So the square root of a squared minus b squared is your C. This is different from the Pythagorean theorem. Don't let it confuse you. And we can go back to GeoGebra and talk about it. Or you can accept the fact that C squared is a squared minus b squared. Save a little time. Then we have one more thing to talk about, and that's the eccentricity. E. Our book likes to talk about the eccentricity or the ovalness or the circularness of our ellipse. How flattened is it, or how close to a circle is it? And the eccentricity can be found by taking C divided by A. If E is close to 0, it's more circular. If E is closer to 1, it's more oval. So here E would be closer to 0, and here E would be closer to 1. So we can see them. All right, ready for next slide? Here we go. So now we have an equation, and we need to put it in standard form so that we can find the center, the foci, the vertices, and the eccentricity of our conic. So when we have x squared plus 4y squared plus 6x minus 8y plus 9 equals 0, what do you think the first step is going to be? Separate x's and y's. So x squared plus 6x, leave a gap, plus 4y squared minus 8y, leave a gap, and let's bring that 9 to the other side. How are we going to get the left side in shape so that we, at least the first one, so that we can find a center, an H and a K? Half the middle term squared. Complete the square. Half of 6 is 3. Squared is 9. Added 9 to the left. Need to add 9 to the right. Half of negative 8 is, well, the problem is we have a 4y squared here, don't we? Pull the 4 out. So when we take that 4 out, we'll have a y squared minus 2y. So half of negative 2 is negative. Because this guy had a 4, right? And so we have to take it out of both of them. So we factor it out of both of them. And then half of negative 2 is, and then squared is, but careful, did we really add 1 here? We added 4, didn't we? So we have to add 4 to the other side as well. Okay. Now, good question. So when we took out this 4, pulled it out in the front, y squared minus 2y, but we didn't really add just a 1 here. The net result is adding 4. Yep, you multiply them. Okay, so since we added 4 to the left, we have to add 4 to the right. Exactly. If we distributed that back out, we would have a 4 that we really added to it. Okay, so now the first term is an x plus 3 quantity squared. We have our 4 out in front and a y minus 1 quantity squared. 9's cancel out and we're left with a 4. So we're just about there. Because what does our standard form say it has to be equal to? Not 0, but 1. Yep. So divide everybody by 4. So we'll have an x plus 3 squared over 4 plus y minus 1 squared. I'm going to put it over 1. You don't have to, but I think it helps us to see what our b is. So 4 over 4 is 1, and we'll have an equals 1. Yep, we're dividing everybody by this 4, so we have a plain old 1 over there. Okay. So the first thing they asked us for was what's the center? -3, 1. Good. Okay. Just like we did with our vertex in the parabolas yesterday, the sign is going to change. Okay. I'm sorry. This 3 comes from here. So our h and k. So first of all, is this a vertical or a horizontal parabola or ellipse? It's similar to a circle, but we've got a 4 down here, and that's our bigger one. So this is like an x minus h squared over a squared, right? Plus our y minus k squared over our b squared equals 1. We have it in the right form. Good question. The bigger one, the major axis, will have the larger a. And the minor axis will have the smaller, the b. Just so that we can see what that number is. It's not necessary. You don't have to have it there. But I think it's easier for us to see that a squared is 4 and b squared is 1 when we hold this place. Okay, we're good? Okay. Because when we factor this, this would be x plus 3 times x plus 3. Perfect square trinomial, which is why we did half the middle term. Okay. All right, we're good? All right, so we know this is horizontal. Our bigger number is the 4. So our a squared is 4. We have a center at -3, 1. If a squared is 4, how much is a? 2. So we're going to move, and our x is the one with the larger value, so we're moving 2 away from x in the x direction on both sides. That's our a. So our because the a squared is 4, so a is 2. That's half the length of my major axis. Okay. What's b? B squared was 1, so b is 1, right? That's my minor axis. So I would go 1 up from the center, 1 down from the center. Okay. If you'd like to see the major and minor axes drawn, you can draw them. And then you draw your oval. And I am terrible at these. They never look like they're supposed to. They always look like footballs, so that's actually not too bad. Okay. So there's our ellipse. What are the values of my vertices? The ordered pairs of the points? -1, 1, right? And -5, 1. Not a circle, so we don't have a radius. This is an ellipse, so that's not applicable. When I moved 2 away, I'm there, and when I move 2 to the right, I'm there. Those are your vertices. I call them the major vertices. The book doesn't necessarily distinguish. It doesn't mention the minor vertices. The points that help us draw that that oval. If we would not have, if we had a 1 underneath each one, then it's going to be a circle. And whatever's over here would be our radius. And if we didn't notice it was a circle and divided them out, we'd have both an A and a B that are the same. We don't really have a radius in this one since it's not a perfect circle. So yep, you just say not applicable. Sometimes they'll sneak a circle in there. And now we just need to find the foci. Okay? We need to see. We need to see how far from the center we need to move left and right. So c squared was what? A squared minus b squared. So a squared was 4. B squared was 1. So c will be the square root of 3. Because the a is always squared, so I just took the square root of each one. So now we know, since c is the square root of 3, we need to go not quite 2 away, right? A little more than 1, because the square root of 3 is 1 point something. So our foci are going to be somewhere over here. And you won't be precise in your graphing of those. As long as you show me it's between 1 and 2 away, we're good. Okay, so a is the number, the larger number underneath your fractions, and b is the smaller, but it's a squared and b squared. So if a squared is 4, then a is 2. And what b squared is 1, so b is 1. Bless you. Yeah. Okay. So our foci are going to be to the right and to the left of the center. When it's a radical, you can combine them as one thing. We're taking -3 plus or minus the square root of 3, comma 1, right? For those points. Or just write them as separately if you want to. The foci are -3 plus the square root of 3, comma 1, and -3 minus the square root of 3, comma 1. But you can save some pencil lead and call it -3 plus or minus the square root of 3, comma 1 if you want, when it's a radical. When they're actually solid numbers, just add and subtract like you need to. Okay? Right. Yep. For today. All right. Eccentricity. Tell me what eccentricity was again. C divided by A. So our C was, and A was 2. So square root of 3 over 2. The E is always a C divided by A. It's our definition for it. So we found C by taking A squared minus B squared into the square root, and then the A was R2. All right, ready for next example? What is the what, I'm sorry? Eccentricity. It's how flat or oval it is, okay? Right. The closer it is to 0 is going to be more of a circular in nature, and the closer to a 1 is going to be more oval. A is always the bigger number. So the A is going to impact whether it's a horizontal or whether it's a vertical ellipse. Okay? All right, so I hear people chatting. That means we're moving on. Ready for the next one. Now we have 9x squared plus 4y squared plus 36x minus 8y plus 4 equals 0. First step, gather your x's, gather your y's, and numbers to the other side. Gather ye rosebuds while ye may, is that what it is? Gather ye. Can't remember. Little poetry. So 9 coming out, x squared plus 4x. 4 coming out, y squared minus 2y. Half of 4 squared. So we have 4, but we aren't actually adding 4, we're adding 36. So add 36 to the other side. Half of negative 2. It's negative 1 squared. But we're not actually adding 1, we're adding 4, so add 4 to the other side. We did that so we'd have a perfect square trinomial. My computer is just about dying. It's getting really slow. Okay, the 36 came from the 9 times 4. Yeah, that's not going to work. That's the Windows. There we go, maybe. I'm running nothing. I don't know. We'll try it. We'll keep going and see what happens. But it's dying here. Okay, so let's keep going. Maybe. Okay, so left side. We have 9 times x plus 2 squared. 4 times y minus 1 squared. 36 on the right side. Divide by 36. X plus 2 squared over 4 plus y minus 1 squared over 9 equals 1. So it helps to plot all 4 just so you can see it. Just the major, yep, just the major vertices. Okay, I lose anybody here? Okay, so now we have a major vertex, right, at 9. So it's going to be a vertical, not a horizontal. So still H and K, my center, negative 2, 1. -2 over 1 up. But this time, my major axis is going up and down. How far up? What is A? Good question. The bigger denominator is going to be your A. Make sense? So it's moving the y, making it bigger. So if a squared is 9, a is 3, that means it's a major, or it's a vertical ellipse. And if b squared is 4, then b is 2. So from our center, we're moving 3 up, 3 down. And 2 right, 2 left. And again, I don't draw very good ellipses. So our vertices are -2, 4, and -2, -2. Our center was -2, 1. The A's, yep. The major vertices is what I typically call them, but the book only asks for majors. Okay? They don't distinguish. To find the vertices, we said, what's my A? A, yep. And so we moved from the center, A in the y direction because the bigger number was underneath the y's. And then that's why I moved 2 this way to get my shape. You're only going to be asked for the major vertices, the vertices on the major axis. And then we need to know our foci. So c squared is equal to what? 9 squared, or 9 minus 4, right? So 9c will be square root of 5. Square root of 5 is a little more than square root of 4, so it's a little more than 2. So we're going to be a little bit more than 2 away. You don't have to graph them. Nope. So 1, 2. Yep. -2, comma 1 plus or minus the square root of 5 if you want to combine them. Or -2 comma 1 plus the square root of 5, -2 comma 1 minus the square root of 5 are our foci. And now we're ready for our eccentricity. Square root of 5 over the delay in my smartboard's driving me crazy all of a sudden. Okay? Make sense? All right. Like I have one more example if you want, but I can give you the assignment. The one more example is just a circle. Okay? We'll look real quick. Okay? If you don't recognize this as a circle and realize that it's x squared plus y squared equals 9, circle centered at 0, 0, radius of 3, right? And you divided everybody by the 9, you'd have x squared over 9 plus y squared over 9 equals 1. That's another hint that it's a circle. Okay, when you have the same denominator. So center at 0, 0, out 3 in 4 directions. Because there was no x minus or y minus. Yep. Complete the square, yep, and you wouldn't have a denominator. That's supposed to be a circle. I don't draw them very well. A radius is 3. No vertices, no foci. Because when we take the square root of 9, we're 3 out, 3 back. How do you know it's the 0, 0? Because there was nothing with the x in the squared term. It's like an x plus 0 or x minus 0 squared, y minus 0 squared. Okay? All right, assignment, and then I'll collect yesterday's. Page 711, 33 to 47 odd. Yep, absolutely. Let me stop my computer so it doesn't fry on me.